an interesting floor equation here for you involving a shifted square root function and then just our good friend, the reciprocal function, 1 over x. Now, the first part of this, I guess you would call it fairly straightforward. You would note most people would want to plug in 13 over 84 right here and observe that the floor is equal to 6. And that's exactly what happens when you put 13 over 84. Note that that's the very first number even in the domain of this function. You couldn't pick 12 over 84 because you would have square root of a negative number. So if you start at 13 over 84, this part becomes 0, and certainly you get a floor of 6. That's easy enough to see. Now, if you substitute the 13 over 84 right here and take the reciprocal, you get 84 over 13. And 84 over 13 is what? 78 plus 6. 78 over 13 plus 6 over 13. So you still maintain the floor of 6 there, right? You have a remainder of 6 when you divide by 13. All right. So anyway, it's very clear that this is a solution. 13 over 84 is a single number that is a solution to this equation. Now let's focus a little bit more just on this left-hand side right here. Here we go. Now, another thing to point out here that will be useful later on in the problem is that we can say more as far as this part goes. Notice that if we run all the way out, if we take this 97 over 84 and substitute it right here, that would just be 97 minus 13, which is, of course, 84 over 84. And that would change this to 1, and so you would have a floor of 7, right? That's why we have this, I don't know if I can highlight this or not. That parentheses right there is everything. You can't, bracket here, we've already seen that 13 over 84 is a solution to both sides. But 97 over 84 is sort of the threshold. It's all the numbers up to, but not including 97 over 84. All right, so this is going to be important. Let's take a look at this part right here. We're going to use it in our next phase here. And remember, we've just focused primarily on the left-hand side here as far as this part goes. Now we'll be focusing on the right-hand side here. When we go down, we'll be analyzing this part. All right, now this took some time for me. These videos are deceptive because I scratched around for 2 hours, on this, but it turns out this is a nice way to characterize threshold levels or floor levels for the 1 over x reciprocal function. Notice I put a member of z, the natural numbers. We primarily work with just z is the integers, but most of the time we just work with natural numbers here. But it does hold for all integers. Now you can take a look right here to verify this is true. If we take k equals 6, which is of interest here, if you put a 6 right there, you get 1 over 6, which you see right here, right? And of course you get 1 over 7. Here, notice we have to leave 1 over 7 out for the very same reasons. If you took the floor, if you put 1 over 7 right here, that would be 1 over 7, which is 7. And we are interested in 6 right now. Okay, so this is what we get. Now, if you couple, and notice I did everything in terms of 84s here. It's more convenient just to check out when these sets actually overlap. Now, this is the result that we got right here. This part is what we got on the previous step, okay, for the square root piece. This part right here is the part, did I do this right? Oh yeah, these parentheses are just crazy, aren't they? But y'all notice how, so we got this for the second piece, but notice how you can see the intersection of these two solutions much easier if you leave the fractions unreduced, okay? So you can see clearly that 12 over 84 is a smaller number than 13 over 84. And also note that if you put 12 over 84 in, like I said earlier, if you try to put 12 over 84 in right here, you'd be taking the square root of a negative number, you get imaginary solutions. So, but in any event, the overlap or the intersection of these two sets is 13 over 84 to 1/6, and that would be the complete solution set. Now, you may ask the question, how do you know when to stop? Well, if you just take a look at what's going on here with K, like K equals 1, 2, 3, 4, 5, 6, you're getting a very small interval. Like in this particular case, you're getting numbers between 0 and 1, right? And you're going to be confined to numbers between 0 and 1 on the interval 0, 1 for all choices, all positive choices of K here, right? 1, 2, 3, 4, 5, you're going to get nothing but relatively small intervals, right, with fractional endpoints. Now, if you go back to this guy right here already, for the left-hand side here, we're getting into numbers that are much bigger than 1. And since this is an increasing function, 97 over 84 is bigger than 1, and that would lead to the floor of 1. And then if you added another 84 to that, what's that? Whatever it is, 181 over 84. So you can see you're getting larger and larger numbers, much greater than 1, when the 1 over x function is just confined to these type of small intervals, meaning numbers between 0 and 1. So we know we're done here because you couldn't have any common x's for other floor levels. 6 is the only time that they're going to touch each other, so to speak. So again, y'all, this is the final solution. Leave some comments if you like this. I think this stuff's very, very interesting, and I hope you enjoyed it.